Welcome everyone to Houston Machine Learning Meetup. Today we are going to look into a position paper on small language models are the future of agentic AI. So if you think about the large language models, these are more like generalists and they are able to perform the general tasks very well. While the small language models are more specialized in certain domain and it can be governed and operated at a much lower cost. Today, this presentation is mainly generated based on this paper. It's a paper, I think, published in mid-September from NVIDIA Research and Georgia Tech. And again, this is a position paper, so it just shows opinion for the agentic AI, and you may agree or disagree with it. The important thing is that we should start the discussion about, what will be the future of agentic AI looks like. Let's start with what is the definition of the small language model. So it's the SLM. So it's a SLM is a language model. So basically you remove the L, the first L from LLM. So it's a language model, LM, that can fit in a common consumer electronic device. So it can be deployed directly on a single device and is able to perform inference with latency sufficiently low to be practical and cheap, right? And then you are able to serve in the agentic requests from any user. And as of 2025, if you're really looking for a threshold about, how many parameters of models are considered as small language model, will be probably around 10 billion. But if that model is 13 billion, I would say it's still a small SLM, right? So it's not a very hard threshold there. But let's say like around 10 billion or below, we will consider it as a SLM. And I believe this threshold maybe is going to increase due to that the hardware is also going to progress, is able to hold models with the larger parameters, and then this threshold will be probably increased in the upcoming years. Okay, so that's the working definition. And then let's look at the comparisons of SLM versus the large language model LLMs. First, of course, is the size, right? So the SLM is much smaller. It's just operating some SLM operating around even millions of parameters, and some is just like 3 billion, 7 billion, and 13 billion. And then the LLM, I would say, is more like in trillions, could be like hundreds of billions, and then it can be in trillions. In terms of the training data set, the SLM is much smaller. The training data set is more focused on specialized tasks, while the LLM is more trained to become a generalist, right? To reason about just like a human being is able to adapt to any new task for broader learning. And in terms of the training, so yeah, SLM could be trained in days or at most weeks, while the LLM, it could take months and lots of GPU to train in terms of the computing resources. In terms of the domain expertise, yes, so SLM is best for simpler and specific tasks, while the LLM is more proficient at more complex and a general task. Okay, so that's in terms of the size, model size, and in terms of the training and computing resources. And then if you look at the operation cost, right, like inference and latency, no doubt SLM will have a huge advantage there, and is able to operate at a single device, and also able to respond very quickly due to the smaller size. In terms of the control, it's much easier to manage. Well, the LLM, I would say, is more like a black box to you, right? So all you can do is just call the API. There's nothing much else. Well, maybe you can still optimize your context, but in terms of the model itself, there's nothing like almost no room for you to play on the model side. But the SLM is more like you have the full control of how you want to train and how you want to govern the small language model. On the performance, so usually the SLM is more adequate for a less complicated and a more fixed scope of task, while the LLM is more, appropriate for more complicated tasks that requires reasonings and also offering able to adapt to new capabilities quickly. Yeah, so that's an overview of the SLM and LLMs. And this NVIDIA paper proposed 3 positions of why they think SLM are the future of agentic AI. The first position opinion is that the small language model is sufficiently powerful and to handle language models in terms of the agentic applications. The second is like more operational, so it's suitable for use in agentic systems than LLMs. And also it's more economical, right? Especially if we want to land the AI for real world applications and for production. Performance, well, performance is important, but the cost is also important. So the SLM is a better fit for the vast majority of language model use cases in agentic systems than the general purpose LLMs, due to their much smaller size of parameters. So based on this, the major kind of the position of opinions that the SLM are the future of agentic AI. And then let's look at more details into this, like why these opinions can hold there. That there's also a motivation for this position. Because this paper is written by the NVIDIA group, and I think they also run a cloud group, right? Developing the solutions for the enterprises. So they have seen the use cases of enterprises pioneering the use of AI. And then they will get feedbacks from their customers. And then they find that companies are looking for ways to increase their margins without compromising the performance of their agents. So basically, simple words is, the customers want the same performance with the LLM, but cheaper. So usually it's like, get the performance first and then cheaper. And then they also find that most of the real world agentic use cases, the majority of the agentic subtasks in the agentic systems are repetitive, scoped, and non-conversational, which means that we don't need a generalist model. We just need a specialist model to handle these repetitive executions. That will lead to a much lower cost of repeatedly calling the models in production. Another thing they see, trend they see is like the customers also want to directly deploy the device on an edge, the model on an edge device, right? Which is basically like such as AI PCs, because I also see like right now the laptop companies are also releasing their AI PCs, and on the laptop itself is able to hold even like a small SLM by itself on the laptop, so that they can secure the personal information without sending every data points to the cloud. And about why SLMs are preferable, yeah, so first is the lower latency. So usually like 10 times or even 30 times lower latency, and also usually lower latency, lower cost, because the model charges, right? So if you have called the say the OpenAI or Bedrock like API calls, usually the billings is based on how many tokens you put, and then also like how many tokens you will get as a response. And there will be usually a throttling limit of how many tokens can be processed within a limited time. So if you're able to deploy the SLM, the response will be much faster, which means that throttling limit will be much higher comparing to the large language models. And also serving the SLM will require much less memory and computational requirement. Yeah, so which is easy to understand. So especially for internal enterprise applications, right? So if we want to deploy in-house models, usually SLM is the best choice for the in-house model deployment. And also it lower the operational costs in terms of the training, and management of the models, which is usually much faster to iterate the model iterations. I also see a question about handling the data shift in the chat. That is a problem, I would say, but in the SLM, you need to continuously maintain the model performance to handle the data shifts. And also the SLM is kind of promoting a more responsible and sustainable AI deployment, right? I think you all see the headlines about the big cloud companies trying to sponsor electricity plant, because in the end, electricity is the upper bound of how much AI computing power like we can get in the end. But if we can sponsor the SLM to handle, well, for majority of the tasks, if the SLM is sufficient, it's going to kind of lower the energy burden and also be responsible for the environment due to the high energy cost of the LLMs. And all of this should happen for maintaining the sufficient task performance comparing to the LLMs in a specific domains. So in this paper, they also mention about two modes of agency. So this is the kind of what we think is the AI agent, right? So usually it starts with a language model. Well, it could be a small language model or large language model, and then this language model is able to do the tool calling, right? So it can be, say, a list of tools hosted on MCP. So there are 2.1, 2.2, and then it can be, some tool can be just another language model call. And then this specialized language model will also has its own specialized tool calling related to that task. So this is the one agency mode. Another agency mode is like they want to more optimize on the LLM cost, because the model cost could be expensive. So how they want to lower the operation costs of the agentic system in production. So instead of like we dedicate everything to the language model, we could separate out the language model, which also could be optional, for the human computer interface. So this language model is more like as a human interface, while at the back scene, you can still develop your code agency. So they call it as a code agency or controller to figure out, oh, what is the tool used for the corresponding intentions of the users. So instead of like dedicating it to the LLM, so based on the use cases, you could basically develop a code agency or a controller to route the corresponding intentions to the corresponding tools in the end. And also all this LM here, since it's not an LLM, it's an LM here, right? So this LM here, maybe we do not need a generalist LM. We need the SLM is sufficient for the corresponding task. So we are going to see more examples next. Okay, so the first position, SLM are sufficiently powerful. So what are the evidence to support this? Like how can you compare the performance of SLM to LLMs? Actually, if you look into industries, there are a series of, I think these are even open source, like small language models that shows comparable performance to like the model of 30 or 40 size larger. Microsoft has a very popular series of SLM called the Phi model. So it's like, I think I have also given a meetup on Phi 2 and Phi 3 models. And then these models, they are able to show that comparing to, like it's just like 3 billion, like 2.7 billion. In terms of the common sense reasoning and code generation, is on par on the performance comparing to a 30 billion model. But it's like a 10 billion, like a 10 times smaller. So it's able to running roughly about like 15 times faster. And also the Phi 3 model, the 7 billion is able to achieve language understanding and common sense reasoning on par with the models of like a 70 billion of the same generation. And also you see that NVIDIA also have a series of small language models, and they are even using the new architecture, like a Mamba transformer models, able to achieve comparable performance to the 30 billion etc. And also DeepMind also has its own SLM called the Retro 7.5 billion model. So this is a retrieval enhanced transformer. It's a 7.5 billion. It's able to achieve performance comparing to the original GPT-3 model while using 25 fewer parameters. And also Salesforce developed this 8 billion model and is able to achieve the state-of-the-art performance on tool calling. So basically, they develop just one language model focusing on figure out like how to call the right tools for the user request. And then it's able to achieve the state-of-the-art performance just on tool calling, comparing to the GPT-4 and Cloud 3.5. So if you look into like, I think this 5 model published December last year. So they also compare the performance across a variety of benchmarks, including scientific Q&As, coding, math, and reading comprehension, reasoning, etc. And these benchmarks, so these are the simple ones. These are more challenging and harder ones. So if you compare the 14 billion model, like a 5.4, which is the latest of the Microsoft's SLMs, comparing it to the GPT-4o, right, which we think is the most powerful closed source LLMs in the market, actually I would say for example, in terms of the scientific Q&As and the math capabilities or the reading reasonings, the gap is not that big, and sometimes it's even better. For example, in terms of the chatbot arena data sets, it's more like actual user Q&As data to evaluate how the LLM is helpful for the humans, is actually able to achieve comparable performance comparing to the GPT-4o over here. And of course, there are some gaps, right? For example, a very difficult benchmark like if evaluation is more instruction following benchmark, you see there's still a big gap of the 5.4 model versus the GPT-4o here. So I would say there will be some domain that the small models are sufficient, while the other domains, yeah, LLM will still have an advantage. But what if we just need the small models for scientific Q&As? Then we can just use a small model. We don't need to run the big model just for that specific list of tasks. So that's the first position, right? So we see that for some tasks, SLM are sufficient. And then next is the SLM are more economical. So this is more on the flexibility of the SLMs in terms of, for example, the inference efficiency, right? The serving the 7 billion is 10 to 30 times cheaper. Yeah, so if the LLM is going to cheaper, SLM is getting even cheaper, I would say. So due to the improvement of the hardware and also the inference and all the infrastructure for the inference, right? So if the LLM is getting cheaper, so is SLM inference is even like 10 times or 30 times cheaper. And then in terms of the fine tuning, right? So yeah, you can do the SLM fine tuning relatively easy in terms of just a few GPU hours. And also there's a trend in the edge development that we want the local execution as the SLMs on a consumer grade GPUs. So one example is the AI PCs. So when I search AI PCs, the first comes up is from HP. And then they have this diagram, and I think it's already in market of what is the AI PC. So it's like a complex AI task directly on your device or in the cloud while boosting performance for your daily work, right? So you want to do like data intensive AI operations such as the machine learning, LLM training and inference, the GPUs like graphics processing, generative AI creation, analyze large data, etc. So I think usually in the AI PCs is the combination of the SLM directly on the device combined with the cloud core, because due to the privacy, you don't want to send all your data to cloud, right? So you can selectively say, oh, some operation I wanted to maintain kind of just run the AI within the device. I don't want it to send to call the cloud API. Well, some like insensitive data or operation, you can still send it to the cloud. I think for any AI PC, there must be some configuration for you to give permission about like what data you want to keep running on the device itself, while the device may still have the AI capability with the SLM. And then what are the public data that or insensitive data you want a performance, like the best performance as possible, all right? And then you can still call the LLM API in the cloud. So I think it will be a hybrid of both. And then I think the next point is parameter utilizations. So there are also research showing that the SLM can make use of their parameters much better than the LLMs. Which means that, so this is what it means of the parameter utilization. So basically people find that for various of the LLMs, well, the example shown here is just 30 billion. So I guess if you increase it to 300 billion, the sparsity will even higher, right? Even if like with the 30 billion, they find that majority of the neurons actually are not activated. So basically they are giving zero output. So it's not activated per inference, which means that you just need a few neurons to complete your task. You don't need all the neurons there. So even on the 30 billion, so this is one study, they show that they show the sparsity is like 97% of the neural activations are zero. So which means that you don't need this big model for your task. And then if you lower the number of parameters to 13 billion or 34 billion, you will kind of, the sparsity will also be lower, right? So that the neurons can get activated and actually utilized for the corresponding task. Okay, so that's the economical. And then let's move on to the operational. Why is like more operational and more suitable, right? So the first is the general flexibility, right? Due to their smaller size, they are more easily to be transported, fine-tuning, edited, investigated. For example, if you find something doesn't work, usually sometimes like say, oh, the LLM fails at this. Like, why LLM is making this mistake? I have no idea. Like, when I just call the API, I have no idea because it's like a black box model to me. Well, in other cases, if you need more flexibility in terms of the interpretation, look into the model in terms of the uncertainty or debugging why the output fails, then the SLM fit in your world of like, it's much easier to investigate. Basically, you have the access to the parameters and output probabilities there, right? So that gives you more ownership and flexibility to deep dive into the models and look at each case by case, like why this works or why that doesn't work. And the second point is the democratization aspect, right? So it's a more SLM is also gives you more diversities in the specialized language model performance. And sometimes if you train a language model just for that domain, sometimes you could get a better performance for your specialized data sets. I already see like the trained model, like a just focus model for document processing, or just a specialized language model for legal space, right? And if you kind of like in the industry, and there are startups on that, right? And then if they are able to kind of own that model, they lower the cost, and at the same time they can just focus on that domain because they don't need other domain. They don't need to care about other domains of the LLM. They just focus on that one domain and make it really good. And then this specialized language model performance actually can get better than LLMs, just for that specific domain. And also, when we developed the agentic AI, right, like a system, we find that the agents usually expose only very narrow language model functionalities. For many of our executions, the problem is fixed. So if you have ever developed the agentic AI, also applies to myself. Usually it's like, oh, you just optimize the problem and the problem is going to be fixed. and then you need to run that workflow, say to thousands or millions of inputs, right? And then get the corresponding output. Only the payload change, only on like how many payloads, how many inflows you need to process with this LLM call with this prompt. And then that could be a little bit a waste of resources, because basically you are just using the LLM for that one single prompt. You don't need the LLM for all the other great capabilities that the LLM has there. So basically it's kind of a little bit wasted of the resources there, especially if your payloads are high. Okay, so the next point is the agents. So basically in the AI agent system, right, it's actually exposed only to a very narrow language model functionality. First is the task specialization. So agentic systems are usually designed for specific tasks. Well, unless you say, oh, just want to have a agentic system that can able to handle all the tasks, then yeah, for sure, you need a large language model. But one of the points here is like, if you need it just for your specific tasks, like domain-specific tasks, say just for medical, all I care about is medical Q&As, or all I care about is math Q&As or coding, right? And then automating these workflows, interacting with the tools, or generating this data could be handled with the SLM. Rather than a general conversation. Yes, so if you want just to have one model that's able to handle all different kinds of Q&As and general requests from the users, I would say that will be still the LLM. And also, usually when you develop the agentic AI, many of these interactions are kind of like require a very rigid formats, right? Like involve structured data formats, predefined workflows. Actually, predefined workflows may handle 80% or maybe 90% of the workflows you need for your enterprise applications. Predetermined actions, and if this is the case, it does not require that complicated reasoning than a general purpose LLM provides. So if your agentic AI applications are task specific, and also it does not require like a complex reasoning, then like the SLM could be sufficient for your agentic AI applications. Okay, and then the next point is the agentic systems are national heterogeneous. So an agent is comprised of many blocks. So heterogeneous means that in terms of the multi-agent architecture, even if the scope is broader, right? If you design a multi-agent system, usually each agent has its own specialty. So each agent is not a general agent. The agent is like a specialized agent, just focused on that specific task. And if that's the case in the multi-agent architecture, then like for each agent, maybe you don't need that. You don't need a generalist. You just need a specialist for that. And there could be like a different levels of expertise in a hierarchy structure to handle specialized tasks. And also in terms of the diverse tools and the APIs, right? So this, so this also contribute to agent heterogeneous nature. So basically, we again, as the diagram, the paper shows, right? In the agency mode, you can choose the LLM to learn how to call these tools. You can also choose SLM to learn, or you can just run a code agency controller to automatically route the user intention to the corresponding tool use. So totally based on the complexity of the workflows and the use cases. I do want to put an example here. So this is the example from our last meetup, right? So on the text to SQL agent system. So there are multiple blockers, right? As we explained last time, right? So there will be retrieve the context, figure out what tables to use, what columns to use. And then there will be a ranking part to kind of retrieve the top most relevant tables and columns to write the queries. And then you pass it in, and there will be a query writer to basically based on the user intentions and write the SQL codes from there. And then in the end, there will be a self-reflection process to run the query, get some errors, and then research on it and try to automatically fix the errors by itself. And you will see lots of LLM call over here, right? Like the table name, re-ranking. So this is like a ranking model. And then there will be a query writer model and then a researcher. And then if you look at this diagram, okay, which of this do I really need an LLM? And which of these can be specialized? Like table name extractor, yeah, a simple model should be sufficient. Or some, I don't know, like even sometimes a syntax parser can be sufficient. Re-ranker, I think this is definitely SLM could be sufficient. Query writers, I think depending on how complicated this is, there could be also SLM just focusing on text to SQL writing, right? I don't need all the reasoning. I don't need all the other mathematical or scientific knowledge. I just want to focus on the text to SQL. So SLM could also be a good fit for this one functionality. Researcher, the only part in this diagram that I think we still need the LLM is the researcher, because the researcher needs to understand all the different resources, need to understand why this error happens, right? So this will require higher capabilities of reasoning here. So if I look at this diagram, the only one that I really need the LLM call is the researcher, because this agent really requires the reasoning capabilities. And then the query fixer maybe is also related to the query writer. It could be shared as a shared SLMs over here. Okay, and then the last one is, since people have been asking about, oh, how can we collect the data to train, right? So the key idea is the agentic interactions are already good natural pathways to gather the data for the future improvement. The idea is you can start deploying with the LLM. You can start deploy your AI, agentic AI with the LLM. And then later, if you find the repeated pattern, and then at the same time, you kind of collect lots of like prompts responses, right? And then, so basically this is your input data to train the SLM. So basically the labels come from the LLM. And then based on the prompts and the responses you see in system, and you find that, oh, it's like a very limited scope. And I actually haven't fully utilized the LLM for this fixed list of tasks. And then I can use these prompts and responses to fine-tune SLM to lower the cost, especially if the payload is high. So I think this is a good mental model. It's like just move fast and deploy with the LLM first. And then based on the patterns you see, based on the payloads you see, right? Like the prompts, the responses, basically your inputs and outputs. If you find that there's a limited scope, you can use this data to fine-tune the SLMs so that you can further lower your operational cost. Okay, so that's on the SLM. So I have talked about lots of the advantages of the SLMs. And then of course, there will be advantages of using LLMs. I'm not saying that LLM is becoming obsolete there, right? So LLM generalists will always have the advantage of more general understanding. This is true, right? So I also mentioned that there's no SLM can beat the benchmarks across all the tasks comparing to LLM. The SLM can only win on, say, 2 or 3, or just a very fixed list, a very scoped list of tasks comparing to the LLM. So this is true, right? So the LLM is still powerful in terms of the general language understanding a variety of tasks. But the SLM, the key point is SLM is sufficient for a narrow scope of tasks to be performed. And usually when we deploy the agentic AI in production, we find that we don't need a generalist. We need a specialist, like a narrow scope of tasks is sufficient for our operation. So that's a key point here. And also another point is, LLM inference will be cheaper because of their centralization. This is also true because like I think Angel Engine also mentioned that the AI is a new electricity, right? So it's kind of, it should be like as easy to use as the new electricity, so that you don't need to manage the model training. You don't need to worry about like maintaining the model, all of that. That is totally true, right? And as I mentioned, like when do we need to consider fine-tune a SLM is totally based on the ROI per use case. So considering that you need to hold like a serve an internal in-house SLM yourself, considering that the serving cost, the maintaining cost of the SLM, so that also has additional cost of serving the SLM, right? But if your payload is high, in terms of like a millions or even higher, then that's worth it, right? But if your payload is like just not even to kind of exceed the cost of doing all this additional serving and maintaining, then there's no point of developing the SLM and serving it by yourself. You should just reuse the API, which kind of save you the cost of doing all this operation by yourself. The third point of alternative use is both the agentic world utilizing the SLMs and utilizing the LLMs are equally possible worlds. I think this is the conclusion of today's talk. I don't want to divert you to say, oh, we should just go use the SLM. That's not the point, but I more want to raise the awareness of when we should consider SLMs, right? So LLM is not the winner for everything. When, in terms of the deployment operation, when we should consider SLM for your applications, right? So yeah, so more likely is the SLM should handle the heavy lifting of the routine task. If you find your task is repeated, it's routine, and your payload is high, right? So basically the number of queries that is high, then you should think about the SLM. And then, but it's for some tasks, it's like a very complicated. It's very hard to scope, like what is needed for that task, right? It can be answering all kinds of queries or requests from the users. Then the LLM still should be reserved for the complex exceptions. And this balance strengthens both approaches and makes the agentic AI more scalable and also more economical for enterprise. And if you talk about it across the board, why companies are not considering this? Well, I mean, the first I think is the sunk cost, especially for the big companies, right? So there's a large amounts of upfront investment into the centralized LLM inference infrastructure. So I think these stories is still being told and being sold. But like in actual execution in a more realistic way, especially for very large scale workload, then the application in the end, customers want both performance and lower cost. And also in terms of the SLM, right now all the performance is still benchmarked on a generalist benchmark. I mean the LLM benchmarks. We still need to develop more kind of benchmarks just for those specialized domain for the SLM training, design, and evaluation. And also there's a lack of popular awareness because I think people will get praised for doing LLM. I don't think people will get rewarded for just only doing SLM, right? Because like LLM is a big world and everyone is rushing to it. But in the end, when we are trying to unblock ourselves for the technical challenges and limits, SLM is still one of our options, so that we can unblock ourselves and we can lower the cost of actually executing the operational workflows repeatedly. And then the last is, okay, how can we say if right now we have a LLM agent, right? And then how can we do that conversion? So this paper, interestingly, they also propose 6 steps about how to convert LLM agent into SLM. So the first is you should have a logging system, right? Like you should log your payloads, log the input outputs for your LLM calls, like input prompts, output responses, what is the content for the two calls, etc. So that you have one place, you have a dashboard to see, oh, which LLM calls has the highest payloads, and can I do some optimization about that? And then once you have this data, so this data actually are the exact training data for the SLM. And usually when you fine tune, well, when I say fine tune, oh, here I would say SFT fine tune. IL is a different story. Using reinforcement learning is a different story. I would say like it's much more difficult to get IL to work than just fine tune with the SFT here. So usually with this is like a 10K to 100K. Based on your kind of logging system, like this is the data you have required, like collected through your LLM course, right? And then you can reuse this data to fine tune the SLMs. And also, you may want to remove some sensitive data, like the personal identification data or the personal health records, to prevent the data leakage there. And then you may want to do some task clustering. So based on how many tasks is required for your agentic AI system, so you can subdivide your data into blocks based on the task performed, right? So you can see, oh, some task is just user intention classification. Yeah, you don't need an LLM for that. It's very easy to classify if that's the first step. And then the data extraction or like a summarization of document types or code generation, right? So you can kind of categorize your LLM course into this specialized domain. And then you can calculate, like what is the payload? Like how many cores are needed for each domain? And then you can prioritize, say, oh, I want to optimize the top payload ones, right? With the LLM with the SLM, so that I can lower the operation cost. And then the next step is you need to choose the SLM. I think there are lots of SLM open source in the market, right? Like the Quen model, the Microsoft Phi model, and I also see that the Microsoft internal use cases, they use the Phi model a lot for their internal use cases, right? So that they can scale across for the high payload use cases. Criteria for the selection, including whether it is instruction following, whether this capability is really important, or do you really require reasoning, then you should more focusing on the SLM with the reasoning capabilities. What is the context window size? That's also someone asked about it, right? So depending on your LLM course, what's your on average or like P percentile 90 context window size for your LLM course, then you should also consider that to make sure that the SLM can handle that context window size. And for specific task types, you should look at the relevant benchmarks to see, what is the base model, the SLM performance for that relevant benchmarks. When I say this, it doesn't mean that you always need to fine tune. Sometimes say if majority of the code generation, for example, right now there are some SLM already performing on par in coding or in mathematical reasoning, right? Then you could deploy with directly use open source SLM to fulfill majority of the your inflows. And then if you say, the code generation failed or the SLM cannot compile the code correctly, you can route the request to a LLM, which means that the majority of your payloads can be handled by SLM, while the remaining, let's say 10%, can be handled by the LLM, which means that these tasks are really complex and we do need the LLM to handle those. And also you need to consider the license. Yeah, usually open source or MIT license, and then the deployment footprint of how we can use and deploy that. Okay, so the step 5 is fine tuning. So I would say this step is optional. You could just directly use open source SLM off the shelf, or if you want to further improve the performance on your internal benchmarks, that will require fine tuning on your curated data. So usually that requires the path techniques. So I have also given a meetup on LoRa and QLoRa. So you can see my channel to understand what is a LoRa, QLoRa. And also you can run some knowledge distillation, which means that right now, since you have a generalist LLM, you can basically use the LLM outputs as your targets to train your SLMs on this task specific data. And then the last is the iteration and refinement, right? So the LLM, I would say, yeah, you have no way to retrain it. Even for LLM, the data could shift. It's just the decay of the performance is much, I would say the life cycle of the LLM is much longer than the LLM, than SLM, because the LLM is like a very, since they have so many parameters, so it's more stable and robust comparing to SLM. Right, so if you have a SLM, you do need to retrain periodically with the new data, so that you prevent the model decaying due to the data shift or the pattern shift of the evolving usage patterns. And I do want to end today's presentation with, this is my favorite conclusion of today. I don't want to say like SLM are the most important, but I think about the agentic AI is a more heterogeneous architecture that involving both LLM and SLM, right? So SLM is more on the heavy lifting of the easy and the routine task. And then the LLM should be reserved for more complicated scenarios that requires reasonings and like a generalist to handle the complexity of the task. So that's the end of today's presentation, and I do have upcoming ones. Like the next Friday is on the context engineering. It's a new cookbook released by Anthropic. And then the next few ones are still focusing on the agentic AI use cases. Yeah, and I have posted my slides and my recordings to my channel. So feel free to check the past ones if you are interested about, the how to fine tune, and if you are interested about the Microsoft Phi model. So you should be able to see my past meetup recordings on specific on those series.